Okay, so now we have a quadratic function that's in factored form. The factored form easily gives us the x-intercepts of the function. So what I'm going to do is I'm just going to list out the x-intercepts just because that's actually going to help us find something else in here. The x-intercepts for solutions are the points intercepts. Those are the points that cross the x-axis. So they're the points that are on the x-axis. So in here, one of the x-intercepts is at x equals 4. So the first x-intercept is 4, 0, and the other one is at minus 2, 0. So the x-intercepts get the opposite signs when they're in the form of x minus p and x minus q. So p and q are the x-intercepts. And now what I want to do is I want to find the vertex. An important trait that the parabolas have is that the vertex is always in the middle of the x-intercepts. So we have a parabola like that. I don't know, something like this. The vertex is here and the x-intercepts are here. So the vertex, the x value of the vertex is right in the middle of the x-intercept. So the vertex is in the x value of the vertex is always going to be right in the middle of the x-intercepts. So what we're going to do is we're going to find the middle value of the x values of the x-intercepts to find our x value of the vertex. So that's what we're going to work with first. So to find the vertex, we know the x-intercepts are located at x equals 4 and x equals minus 2. So to find the x value of the vertex, we're just going to find the average of these two numbers to help us find the middle number. So we're going to add 4 plus negative 2, divide that by 2 to find the number in the middle. So 4 plus negative 2 equals 2, divided by 2. So x equals 1 is the x value of the vertex of this quadratic function. And 1 would be the number in the middle of 4 and negative 2. And now to find the y value of the vertex, we take this value of x equals 1 and plug it back into the original function. So we're going to get y equals 1 minus 4 and then 1 plus 2. So then we're going to get 1 minus 4 is negative 3. 1 plus 2 should be positive 3. So the y value of the vertex is negative 9. So our vertex is a point 1 comma negative 9. So I'll write it right here and box it. One comma negative 9, like that. That's a little sloppy, so I'll write it over here. 1 comma negative 9 is going to be the point where my vertex is at. So the axis of symmetry is the x value of the vertex because that's going to be the line of symmetry of the parabola. So at the vertex is where we have symmetry. So x equals 1 is going to be the line symmetry. So we have symmetry at the vertex, but if we want the specific line of symmetry, that is the x value of the vertex. And now we want to know if we have a maximum or minimum value. Right here, the leading coefficient, so a is positive 1. So for this one, we know that a is 1. We don't see it, but if you multiply 1 times all of this, you're going to get the same function. And because a is positive 1, that means that our parabola is going to be opening up like that. So we're going to have a minimum value. So we're going to have a minimum value at, and the minimum y value is going to be negative 9. That is because a vertex always represents the highest or the lowest point of the parabola. In this case, a vertex is going to be the lowest point of the parabola. Now we're going to find our y-intercept. The y-intercept, you have to set x equal to 0 into the original function. So y equals negative 4 times 2. Y equals negative 8 is the y value of the y-intercept. So the point 0 minus 8 is the y-intercept. Now I'm ready to start graphing my parabola. Oops. So first what I want to do is I'm going to graph my vertex. The vertex is a point 1 minus 9. So 1 minus 9 is right here. That is my vertex. Now I'm going to graph the line of symmetry that represents symmetry in the parabola. So x equals 1 is the line of symmetry, also known as the axis of symmetry. The y-intercept is a point 0 minus 8. So the point 0 minus 8 is right here. That is the y-intercept. And we notice that the y-intercept is 1 unit away from the axis of symmetry. So we can get another free point that's a reflection of the y-intercept. The point that's a reflection of the y-intercept is also going to be 1 unit away from the axis of symmetry. So both of those points are symmetrical. And right here, this quadratic function easily gave us the x-intercept, so we could graph the x-intercepts already. So one of the x-intercepts is at x equals 4. The other x-intercept is at x equals minus 2. And now we can draw our graph. And we can notice our parabola opens up. Like that. There you go. So that's your parabola.